here in Southern California. Precisely, we're in Anaheim, California. It's kind of a little far south of, well, it's in OC, which is a little far south of LA, where OJ was doing that, running through those airports. We're talking to some people about space. Space is a real good thing, where people kind of forgot about it after they went to the moon. They forgot about space, but it's always been out there. It's big, and what now they're working on in the NASA down there is as you can see, is coming up in this here space shuttle. They're making a space station, and this is not like what you think about, like a broadcast and television station. It's actually making a town up there. And what's good about it is they're working in the unit 100 yards. Now, you know me, we always figure out things as 100 yards is almost as good as a cubit. You get in there and you can do these athletic astronauts. They can get in there and they can do them 100-yard dashes, and it's good for scientific measurement, see how fast they are, because they want to see if they come back down here and win the Olympics. Because then that'd make NASA get real here at a big science convention. It's the American Association for the Advancement of Science. They want to kind of push science into the future, and there's some people here who are really they're the most futuristic people I've probably ever seen on the planet Earth, because they're thinking about the planet Mars, and we're going to talk to them because they got some real innovative ideas, and they remind me of the statue of the thinker, kind of like 12 statues of the thinker that are really thinking real hard. We're here with Derek Shannon of the Mars Society in Southern California. You're located at Caltech, is that right?
Yep, we're with the Caltech chapter of the Mars Society. We have over 72 chapters worldwide that have been founded since our major international founding, which took place in August of last year.
So you're at this pretty full on here at the AAAS Convention, trying to get the public interested, and as well as government interested in funding an eventual occupation on Mars by humans.
Yep, we're dedicated to increasing the research and science and knowledge that we have about Mars, and that could very easily lead to a permanent human presence on Mars, depending, of course, on how our efforts go. The important thing is that we take advantage of the technological capabilities that we have right now and turn that into a political decision to actually go to Mars. It's important that we carry out our own sort of private endeavors, such as the Mars Arctic base that's being put up by the year 2000 in the Northwest Territories of Canada, where we'll be learning about Mars.
This is in that crater up there where you're trying to do science in the crater to try to figure out how to do it on Mars.
Yep, in the hot
like
crater.
A dry run. Well, now, what kind of society, how's it structured? How you set it up?
Well, it's a very modern organization in terms of we were able to take advantage of all the current resources of the internet and email, and basically have a very coherent and comprehensive organization that way, where it's very easy to keep in contact with members, and where it's very easy to get the information out, while at the same time preserving the sense of contact and friendship that comes along with any society.
But it's a .org, not a .com.
Yeah, it's a .org. We're a non-profit organization, independent of the government, that's going to be going out and doing its own series of progressively more ambitious missions, starting with the Mars Arctic base, that are going to be getting us closer to humans on Mars.
Right now, in 1999, nobody's really 100% sure that you could actually get people up there yet. And like how in your literature that I read, that was kind of curious to me, that you was talking about the Earth being a sister planet. But I always thought the sister planet of Mars was Venus, and that the Earth was a mother planet. Is this just kind of like, are you just trying to find a good metaphor, or what's the deal about that?
Well, Mars is by far the body in the solar system that's more similar to Earth than anything else. I mean, Venus has a much similar size
like LA
and gravity
over the whole planet, right? I mean, it's really got smog. Don't go there.
Yeah, Venus is very warm and in a hospitable place, and we're definitely not going to be sending humans there anytime soon.
And
but
Mercury's
Mars
too close for the terrestrial planets. It's just a little too close for comfort. We wouldn't want to go to that beach.
Yep, but Mars, on the other hand, has the resources, the atmosphere, out of which we could make rocket fuel for our return trip home after we send people there.
That's real interesting. That's what I was reading about that. Because one of the deals about getting there is you have to take a whole load of fuel up. That's a lot of weight to carry just to come back with. You want to tank up there, so that you're figuring to set up a situation where you're using taking hydrogen, right, and trying to and use it with this is with what kind of explain that, because that's real. That's the most fascinating part about this whole thing. It's sort of like if Lewis and Clark went out, they'd make their own horse at the other end.
That's sort of one of our most popular analogies to explain it. We'll be using just that 6 tons of hydrogen to create over 100 tons of methane and oxygen out of the Martian atmosphere.
Like the first filling station on Mars.
Yeah, absolutely. We'll have that carbon dioxide to combine with our hydrogen. We'll take away the oxygen, and in the end, we'll come up with the fuel we need to get back. That is, if the astronauts really want to come back.
You use the word inserting into orbit. Now, what kind of explain what that means? Because that sounds like there's a real precise target hole you got to hit to do all that right.
Well, it is a precision maneuver. If something goes wrong, there's little need to worry when we do send humans out there, because sort of like in Apollo 13, they'll be on a free return. Yeah, they'll be on a free return trajectory, which means they can go around, swoop around Mars, and come back without expending any additional fuel. So
they'd be real disappointed because they wouldn't have landed, right?
Absolutely.
Answer me this, because as you were saying that, I was just thinking about how the Apollo did it. They always left one guy in orbit, kind of as a safety kind of thing, I guess. And you're not going to do that, though. Everybody who goes is going to land. Is that right?
Yes. Landing on the surface is really the safest place to be on Mars. For instance, the Martian atmosphere screens out some of the radiation that would have an harmful effect if there was too much of it. And so, in addition,
like solar flares
exactly, solar flares, cosmic radiation, that sort of thing. It's less of a problem if you're on the planet. And furthermore, since we're going to have such a long stay on Mars, perhaps 500 to 600 days, you'd get pretty bored if you're the only person stuck on the space station going around and around.
One thing you talk about in your literature too is that you're looking at it as a kind of a polar mission. I mean, you're doing polar missions on Earth because there's places that seem more similar to the Martian environment, and then when you go into the poles, partly because the ice and the water is there. Is that right?
Well, yes, the water that's on the surface of Mars is, of course, all frozen or else sublimed in the atmosphere in very small concentrations. And Mars does have the polar ice caps, but for our manned missions, we probably will not go to the poles and land at the poles, because it's a little harder to take off, because when we land at the equator, we have Mars's rotation that adds to our orbital velocity.
Spin it off.
Yeah, but with the rovers that we'll be able to take along, some of the plans for rovers, they can either be, there's some plans for over 300 there and back capable rover, 300 kilometers or 500 kilometers, and some plans even call for sort of one that would be as in perpetual motion as perhaps a nuclear submarine here on Earth. We'd send out a rover and it could pretty much keep going and going as long as it had food. And so that would allow the capabilities to still be able to reach the poles even when we land at the equator, although it would be a very long trip.